Hello friends, welcome to another lecture of vector calculus. This is lecture number 4, okay, mathematical physics, and this video is for the MSc and BSc students. Okay, now let me tell you what are the topics we are going to discuss in this video. And topics we are going to discuss is scalar triple product and its geometrical interpretation. Okay, and also we are going to solve some problems as well related to this topic, right? And link of the previous lectures are given in the description box. Watch them, and if you are new to my channel, please subscribe the channel, hit the thumbs up button as well as bell icon. And if you think my videos are helpful, then do share with your friends. So now let's start. Now you see scalar triple product of three vectors, suppose a, b and c, is written as, within square bracket you can write dot product or scalar triple product of three vectors a, b, c, or you can write this one a dot b cross c. That way also it can be written. So now you see, suppose vector a is this, this is the a vector, and vector b this one, b1 I cap, b2 j cap, b3 k cap, and similarly c vector is this, c1 I cap, c2 j cap, c3 k cap. Then a dot b cross c is given by this determinant. Okay, this determinants. So let me show you how we have got this result. Let me show you in the next slide. Now you see, let me rewrite the vectors. This is vector a, this is c, and this is vector b. Okay, this is vector b. Now let us find b cross c first. With the help of determinants we can find b cross c this way, right? So if you find b cross c, then I into that b into c3, right? Then b2 into c3, then when you take I, then b2 into c3 minus b3 into c2, right? Then when you take minus j cap, when you take j cap, then what you should take, b1 c3, right? Then minus c1 b3, then plus k cap, this is k cap, then b1 c2 c2 b1, right? So if you find a dot b cross c, then you will get, you have to multiply this vector a with b cross c, right? A1 should be multiplied with this part, right? Similarly a2 should be multiplied with this part. Then similarly here you see this a3 should be multiplied with this part, so a3 will be this one, right? So if you compare with a1 a2 a3 with I cap, j cap and k cap, so this determinant can be rewritten as this expression can be written in this form of determinant, right? If you compare a1 a2 a3 with I cap, then you can write this, right? So this is the result. That's how we got. So hope you have understood this. So here what we have done, we have expressed this result in terms of determinants, right? If you compare this a1 with I cap, a2 with j cap, and a3 with k cap, if this determinants gives this expression, then if you replace I, j and k by a1, a2 and a3, then you will get this determinant, right? Hope you have understood this. So now you see one more important thing, that if you take scalar product of a vector a, b and c, and then scalar product of b, c and a in this order, and then scalar product of c, a and b, so these all three results are same. So let me take a question, so that vector product of a vector, b vector, c vector is equal to vector scalar product of this scalar triple product of a vector, b vector, c vector, and scalar triple product of b vector, c vector, a vector equal to, and that of c vector, a vector, b vector. So that means A dot B cross C then is equal to B dot C cross A is equal to C dot A cross B. So let me show you how. So let me prove this. So let us write the A vector is this: A1 I cap, A2 J cap, A3 K cap. B vector is this: B1 I cap, B2 J cap, B3 K cap. And C vector is this: C1 I cap, C2 J cap, C3 K cap. Right? So we know that A dot B cross C is given by this determinant, that is A1, A2, A3, then B1, B2, B3, then C1, C2, C3. Right? So then if you find B dot C cross A, then its result will be given by this determinant: B1, B2, B3, then C1, C2, C3, and A1, A2, A3. Right? So then what we can do? This is going to be equal to minus, if you interchange any two rows or column in a determinant, then sign before the determinant will be changed. Here you have positive, so it's become negative now, right? So hope you have understood this. So now you see, let me interchange row 2 and row 3. So then what you will get? You will get this: B1, B2, B3, A1, A2, A3, C1, C2, C3. So what we have done, row 1 and 2, 2 and 3 are interchanged. So this that's why this minus comes here, right? So if you interchange the first and second row, right, first and second row, then one more minus comes here. So that's why this minus will be plus, right? Then you will get this determinant, right? Interchanging row 1 and 2. So let me write equation number 1 here and equation number 2, right? So here you can see these two results are same. So let me show you that C dot A cross B also same. C dot A cross B. If you find it, then you should get C1, C2, C3, A1, A2, A3, B1, B2, B3. So now let me interchange these two rows, first and second, right? Then minus determinant A1, A2, A3, C1, C2, C3, B1, B2, B3. What we have done, we have interchanged R1, R2, right? Then let us interchange third and second row. Then one more minus, so it's become plus, right? Then A1, A2, B1, B2, A1, A2, A3, B1, B2, B3, and C1, C2, C3. You will get this after interchanging row 2 and 3. So this is equation number 3. Now from all these three equations, if you compare the values of these three result, if you see equation number 1, 2, and 3, if you compare these determinants, you have the same determinant here. That means you have the same value of these three results: A dot B cross C, then B dot C cross A, then C dot A cross B. So from equation number 1, 2, and 3, what we can write, that A dot B cross C is equal to B dot C cross A, then C dot A cross B are equal. So hope you have understood this. So that's how we can prove this. This is very important question. Okay, so now let us discuss about geometrical interpretation of this scalar triple product of three vectors. So let me draw three vectors first. These are the three vectors, co-initial vectors. Then if you, now let us complete a parallelopiped. So if you complete this way, a parallelopiped, and these are co-initial vectors, A, B, C are co-initial, means their initial points are the same. So initial point is the same of these three vectors. So here you see, what do you mean by parallelopiped? So this is different from cuboid. All the cuboids are parallelopiped, but not all the parallelopiped are cuboids, because in cuboid, here you see angle between two planes is 90. Here it is not necessary to be 90, right? So that is the different. Okay, so hope you have understood this. So then you see, let me write A dot B cross C. What does it represent? So A dot B cross C. So B cross C is nothing but what? BC sin theta n cap, right? BC sin theta, cross product of two vectors is magnitude of the two vectors and sin theta n cap, right? So here BC sin theta gives the area of this parallelogram, base area, right? Area of the parallelogram ABCD, right? Where theta is the angle between B and C, right? and the direction of the resultant of B cross C will be given by this n vector, right, which is perpendicular to both B and C. B and C, right? Now you see, if the angle between A and n cap is suppose phi, angle between vector A and n cap is phi, then A dot n cap, this A dot n cap is given by A dot 1 dot cos phi, because this n cap is the unit vector, its magnitude will be 1, so we will get A cos phi. Now if you draw a perpendicular here, you can see if you draw this perpendicular PM, right, from this point to AB, from this vertex, from this vertex P to the side AB, then you will get this triangle PMA, and here this angle, you can see this angle, these two angles are equal, alternate interior angles, so this one will be also phi. So this is vector A. From here PM will be the, so what does PM means here? Height, distance, perpendicular distance between these two planes. You can see perpendicular distance between these two planes, right? So that means height of the parallelepiped. So that's why cos phi will be given by PM by AP, right? So PM will be equal to AP into cos phi, right? So AP is the vector A, so length of AP will be the magnitude of vector A, that is A, right? A cos phi is the distance between the opposite parallel planes, right? So hope you have understood. Now here you see, this is nothing but base area. This BC sin theta is the base area, and this A dot n cap represents height of the parallelepiped. So therefore A dot B cross C represents that this is base area of the parallelogram ABCD is the base, right, into height, that is PM, that gives base area into height, it's gonna give you volume, right, volume of the parallelepiped. So now remember, if the volume is 0, if the volume of the parallelepiped is 0, then these three vectors A, B, C must be lying in the same plane, they must be coplanar, okay, remember this property. So let me make a correction here. If you see, if you take this side as B vector and this is a C vector, and if you apply the right hand thumb rule, then this direction of this normal vector, normal unit vector should be downward, okay. So if you find B cross C and if you apply the right hand thumb rule, then this should be downward actually, okay. So this is the geometrical interpretation of scalar triple product. So now here you see, let me take a question, determine lambda such that these three vectors, A vector is this, B vector is this, and this is the C vector, so these are coplanar. So let me rewrite the given vectors. These are the three vectors given. So if these vectors are coplanar, then according to the question, these vectors are coplanar, right? If so, then this must be equal to 0, right? Scalar triple product of these three vectors must be 0. So now we know how to find the scalar triple product A dot B cross C using determinants. So then here you see, from this A vector we will get A1, A2, A3 is 1, 1, 1, right? Then B1, B2, B3, here you will get 2, 0, minus 4. As 0 is missing in this vector, so J is missing in this vector, J cap is missing, so you can consider 0 into J cap, and from this vector 1 lambda 3. So these are the C1, C2, C3 from are obtained from this vector, right? So the right hand side equal to 0. So you know how to evaluate determinants. So let me evaluate this determinant, right? So then what you will get, let me do here. So after calculation of these three terms, you will get this is equal to 0. Now from here 6 lambda will be equal to plus 10, and that's going to be equal to 10 by 6, that's going to be equal to 5 by 3. So this is your value, of lambda. This is your result. So this is your answer. So that's how we can. So let us show another question. So that the 4 points, these are the actually position vector of the 4 points, are collinear. These are collinear. Okay. So sorry, coplanar. So let me take 4 points in a Cartesian system, coordinate system, and these 4 are the given 4 vectors are the position vectors of these 4 points. So these are the position vectors, right? So now you see, to show these 4 points are coplanar, we are going to show AB vector, BC vector, CD vector are coplanar, right? So suppose the 4 points A, B, C, D be the 4 points whose position vectors are given vectors, respectively small a is this, vector small b is this, and C is this one, and D is this one, right? So these are the position vectors of the 4 points A, B, C, D, right, respectively. Now AB vector, initial minus terminal, terminal minus initial point, that is here terminal point vector is this one, position vector of the terminal point is this b, small b, and initial is this one, small a. So b minus a. If you do this, then what you're gonna get, this one you're going to have, right? So this results this vector. Similarly, let's find BC. So then C vector minus B vector, right? So you are going to get this result. Then CD, D minus C, and you are going to get this result. So hope you know this how to find. So let me clean this figure. Okay, I have drawn this figure in order to explain only. This is not necessary, so let me clean it. So now let's find AB cross BC, AB vector dot BC cross CD vector, BC vector cross CD vector. Using determinants you can find, right? So your A1, A2, A3 will be 9 minus 5, 2, right? And B1, B2, B3 will be 9 minus 1, and C1, C2, C3 will be minus 18 plus 10 minus 4, right? So let's determine this determinant. So 9 into this, then minus 5 into minus 5, and that's what we're gonna get. Then 2 into this 2 and this 2, right? So you know, I hope you know this how to determine this determinant, right? So if you calculate those things, then what you gonna get, this one, minus 234 minus 130, 364, and sum up the negative numbers, then you will get this, and it's gonna be 0. So this 0 means these 3 vectors, AB vector, BC vector, CD vector, are coplanar, right? Vector AB, BC, CD are coplanar, which means the 4 points A, B, C, D are coplanar. So that's how we can solve. So hope you have understood, and if you have understood, please share with your friends, and if you like the video, hit the thumbs up button and inspire me to create new contents for you. And if you are new to my channel, subscribe the channel as well, and hit the thumbs up, hit the bell icon so that you get notified when new video is uploaded. So thank you for watching. See you in the next video.